John says Neovermispist says.
Whoa.
Whoa. Spectre, thank you for the 28 months. For God's sakes. Crazy. Good morning, Spectre. 28 months. Following for almost 3 years, Spectre. Thank you.
Dead says.
LFG.
Dr. Dead Click,
Neovermispist
what's
says.
up?
Wow.
Welcome back. Yeah, Spectre, that's a long time, man. Thank you. Thank you for all the help, all the support, all the chit-chatting. Thank you.
Hack the Planet says.
Morning.
Morning,
John says
Tagora.
Neovermispist says.
Now, if only I was 25% as productive as you.
I don't know about
Lord.
productive. I
Dead
feel like
Click
I'm
says.
treading water right now.
Yo.
Translated from
Well, Dr.
Estonian.
Dead Click, hope all is well. Good to see you. Tagore, I should try that right now before I get too sidetracked. Can I do it on stream? What is that? Code Maestro. I don't even.
John says Neovermispist says.
I feel I haven't made any progress in knowledge or life since 2020.
It's tough, man. You should not be beating yourself up. There's other circumstances that you are attending to. Honestly.
Hack the Planet says.
Yeah, I don't know how open we'll interact, but let's FAFO. D.
Okay.
John says Neovermispist says.
That's true, but I also waste a lot of time, lol.
Okay. Well.
Hack the Planet says.
You're not going to get a
Open will display my public IP, so keep that on another screen. D.
okay, can do. I'm not gonna beat you up, Spectre. But okay, there's the VPN. But as always, if you need help, like motivation, let me know. I'm usually up bright and early. Usually. These past 2 weeks have been hard, I'm not gonna lie. Past 2 weeks have been hard.
The only way to learn is by playing. The only way to win is by learning, and the only way to begin is by beginning.
That. Dr. Dead Click, what are you up to today?
Nothing in this world that's worth having comes easy.
Yeah, that's true. That's true right there, man. Okay. Where should I put... The VPN is going to be...
Hopefully we don't have overlapping private IP spaces. D.
I don't think so. I wouldn't think so.
John says Neovermispist says.
I cleaned some last night, but today is a big clean day to get set up for my new office space.
Okay, so you're moving because you had everything set up in a room, but you're changing that, right? Which is fine. I'm trying to understand the logistics of it. Okay, so do I want... I'm trying to
Moving out of the 10
understand.
by 11 room.
So can I connect to... So I would run the GNS3 server. I'm sorry, GNS3 software. I mean, I could run it on any operating system. But then I
Hack the
connect
Planet
to it,
says,
Yeah, you can run the client right there from Windows.
and then I connect to your server
John says Neovermispus
through
says,
the GNS
And clearing
software.
out the living room, dining room, and workout area and taking that over.
Okay, that's right. I remember you saying that. Hey there, an account. I believe I have an account. Don't be looking at my password. So,
Hacked.
Hack the Planet says,
Yay, the server is just a specifically configured Ubuntu VM.
okay. I think I understand. I think I understand how it works. Excuse me. I'm still on my, had a cup of coffee on my first 24 ounces of water. 26. I forget how big this thing is. I think it's 26. That's the company my brother works for. It's backwards. It's a cool logo, right?
Usually my coffee to water ratio is inverted. D.
Yeah, I know. I tell you, man, that shit scared me last year. The walking pneumonia, man, that scared the shit out of me. Start menu folder, that's fine. So what is this? Components you want to check on
Loaf
GNS3
says,
web client, GNS3
Plenty of water
VM.
and a cup of coffee. Smile, smile.
That's not how it works. I agree. I thought that was how it worked too, but no. Nope. Good old fashioned crystal clear right from the reservoir. Okay, I didn't know if I needed something else. Good morning, Loaf. Good to see ya. How are you? What's going on?
Hack the Planet says,
Default options should be fine here.
John says Neovermispus says,
Tea will get you hydrated.
Nope. Can't argue with me on this one. I mean, you can argue with me, but you're not gonna. Nope. Nope. Water. Water and exercise make me feel great.
It will too.
Okay, sure, but I'm not changing. I'm not changing what I'm doing.
2.
Loaf says,
Helped my friend surprise his wife today with a 12-inch Dobsonian telescope. They had a round trip of nearly 5 to 6 hours to get it and take it home. He got her up here under the guise of going ice skating and she fought him tooth and nail to not come, but he managed to convince her. XD.
Cool.
John says Neovermispus says,
Lol.
Hack the Planet says,
There are a couple of tools that it asks an email to install. They are good tools, so give it a junk email address for them to send their junk mail to. D.
Loaf says,
Okay.
How has your week been?
Love, I'm not sure if you've heard, Doge caught up to the contract that my employer that I was employed by. 50 of us lost our jobs. So the week has been okay. I've been busy. I got about 35 applications out now. I actually heard back from someone for a systems administration position. Did an initial call, and then we're going to be, I'm waiting on a invite for an in-person interview. I agree. Accept.
John says Neovermispist says.
Oh, this is it?
You up and wait yet?
Loaf says.
I did see that stream replay. I'm so happy for you to be looking at sysadmin jobs greater than D. Dark side unite.
It's you. You and Segura. I still want to do security stuff, and I think I'll be able to. I still think I'll be able to. But I can't be doing this. I can't be doing this every year. It's just, I can't be doing this every year. There's stuff that I need to accomplish for my family. Anyways. So I think the sysadmin stuff will help. I think the system administration stuff is going to help. Okay, so this is the one you were talking about, Tagora. I really don't have a junk. I mean, I do, but I can unsubscribe.
The planet says.
I like system administration jobs because when everyone else gets laid off, we're still there.
Yeah.
Loaf says.
Yep.
At least it'll be a stepping stone to getting back on the hack wagon.
Yeah. Yeah. Yep, I agree. Yeah, so these things look unlike anything I have ever seen.
Loaf says.
Life has many detours and diverging paths, but you can always get back to where you want to be given enough time and effort.
Hack the Planet says.
Hacking also makes me a better system administrator, so nothing is lost.
Yeah, agree.
Loaf says.
Agree.
It's the bottom left white one.
Thank you.
BT 350 I think it was.
I think it looks like it should be installed on the roof of a, you know what I mean? Looks so official.
It's taller than me. XD.
Translated from Spanish.
Hold the phone. 12 inches is this? I thought that meant like the height of it, or the, I don't know. That's a ruler. I don't have one down
Yeah.
here. That's like this thing.
12 inches is the lens diameter.
That's
XD.
stupid.
I barely managed to fit this in my car.
Hack the Planet says.
12-inch diameter.
Good
So
lord.
round.
Holy shit! Is that what it looks like? My head was like, oh, I guess you could find a table to put that on. Oh my god.
Loaf says.
It's a man's 12 inches.
Wow. Well, cool. And did she like the surprise? She had to have. This seems like it'd be very cool.
Hack the Planet says.
I don't know what to do with 6 inches. What in the hell would I do with 12?
Where'd it go? Over here. Next, complete. Would you like 20 plus network performance management monitoring and troubleshooting tools for free? Am I
Loaf
supposed to say
says.
yes here? This is
They both cried.
SolarWinds.
It was such a happy,
No.
adrenaline moment for them both in very different ways.
Oh, very
Hack the
cool.
Planet says.
No.
Yes is clearly bolden. I think I'm supposed to click yes, but I'm glad that you're here. Start GNS3. Thank you. Browser pop-up. I already saw that. No thank you. It didn't start.
Loaf says.
Oh, I almost started
Are you guys
painful
looking
IT
up
bot.
some emulated networks?
So here is here's the position. He mentioned Cisco firewalls, but they are moving. He says they've started and getting rid of Cisco stuff. They're a Juniper house. So to that end, I've already done the initial call. So I want to have, yeah. So Tagora's got, what did you describe it as? GNS3 with Juno's router, switch, and an Ubuntu desktop image
John says
on
he
his
never missed what
infrastructure.
it says.
Cisco is down.
So I want to be able to get that, you know, at least some experience, so I can go into the in-person interview with. No, I don't have
Loaf says.
enterprise experience, but I
Nice.
have. In fact, we have a better way to say that. I'm familiar with how to administrate networks generally. I've been preparing for entry-level Juniper certifications.
Hack the Planet says.
GNS remote server is
Thank
what
you.
you'll choose here.
Got me. Run appliances on a remote server. Advanced usage. Next. Local host 3080. I mean, can that be smaller? 3080. Enable authentication. Is that what I got to change? I got to change this. What is this?
Host is 192.168.0.113.
John says Neovamisbus says.
That's what she said.
3080. X admin.
Hack the Planet says.
Authentication is the details I provided.
Got it. Okay, no one look at the password. I don't know what, I have no idea what was in there. Next. Oh wait, I didn't run the VPN. I need to run the VPN, don't I? It is, skipping. It is downloaded. Oh, you didn't see his face. Good. That was the guy. I record if I do. If I do calls,
Yay,
I
open
record them in case I
connection
need to go
required.
back and
D.
remember something.
Yay, so hide the public IP here.
I'm not sure. What was that? I'm not sure what's going to come up here. So I believe I have OpenVPN installed.
John says Neovamisbus says.
Poof.
Did you get
Shh. Import, yes. Okay, this is the private, so it's off screen now. Connect. Okie dokie. And now back to GNS3. Hold on.
Hack the Planet says.
We blurred. D.
Back. Okay, let's try it again. I think that's it. How can I tell where the connection is?
So now you're connected.
And that's from this. Right.
Now start a new project.
All right.
Now you can start adding things like switch router, etc.
Okay. I've only done this a few times, and I it's been so long, but I feel like I should start with internet access. What do you have on yours? NAT 1. Or should I, maybe I should start with the endpoints. Let's start with the endpoints.
Hack the Planet says,
The icons on the left are where your resources are.
Okay.
Nick says,
Lurk and smile, smile.
Yo, DM Nick. How's that Splitgate treating you?
Hack the Planet says,
So drop in an Ubuntu guest.
Okay. There's an Ubuntu guest. I don't know what. You got Cloud here, you got Nat. I'm just trying to recreate what you had. So here's a Nat.
You'll see on the right that it's off by default.
Okay. Let's turn it on. Start. That was fast. All right. Let's do a switch.
Now, as a simple test, just create a connection directly from Ubuntu to the NAT.
Okay. Let me see. Oh. Hold on. Oh, is it this?
Mad Max Voltron says,
Oh no, packet tracer, my worst fear.
Hack the Planet says,
So click the wire. Then click the device.
Oh, okay. 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 So, dumb question time. Something I should really know, but I keep, and I think I've seen this at one time or another.
So this is like connecting the physical Ethernet port to the physical router port.
Okay. Physical Ethernet port to the physical router port. Oh, it says, yeah, this is the wire connecting the Ethernet port on our Ubuntu desktop to a port on the router.
Now double-click the Ubuntu desktop to get a session.
Okay, hold on. ETH stands for Ethernet. 0 means the first one. WLAN is the wireless. LO.
After deselecting the wire,
Simply Sure says.
Hi.
Hi, Simply Sure.
Hack the Planet says.
double click or click console.
Oh, okay. I was clicking, I was right clicking, then play. Simply Shaw, welcome back. How you doing?
Password is the same as the user for these test boxes.
So OS boxes.
Mad Max Voltro says.
What are we creating or hacking RN?
Simply Sure says.
Good. How are you doing, sir?
Good. Thank you for asking. Mad Max Voltro. Voltro, Mad Max. I'm becoming familiar with basic networking and using Juniper devices. Good question.
Mad Max Voltro says.
Oh, nice.
Okay.
Hack the Planet says.
So now just to confirm the connection, click on a browser and search for homemade waffles on Google.
Is it waffle specific?
Mad Max Voltro says.
I once tried packet tracing, etc., and I got lobotomized from it, never touching it again.
Well, everyone's got their reasons. Mine is because I have an opportunity with another, I have an opportunity I'm trying to pursue.
Hack the Planet says.
It's either that or porn, but porn is probably cached already.
Probably. I mean, it's moving. We have Twitch. It's just, you know. Hey, there it is. Works like a charm. Waffles, though? Trying to get live video, maybe straining it. This is not what we're trying to do. We're just trying to test connectivity, and it's moving. Okay.
So now you know the kind of end state you're looking for when you put some intermediate devices between that endpoint and the NAT gateway.
Got it. Okay.
Mad Max Voltro says,
What else do you guys suggest is the most secure to run some services on for a law firm so I can have anything be vulnerable?
Mad
Can't.
Max Voltro says,
Can't.
translated from Dutch.
It's always gonna be. Actually, like, you should start with, perhaps, like, I'm sure there's
Hack the Planet says,
Yeah, it's weird. Device labeling is inconsistent. ETH0 in GNS3 is labeled as ENS3 on the Ubuntu machine.
ENS3. Yeah, Mad Max, you may want to start with not certifications. What am I trying to say? It may be industry standard, especially for law firms. Compliance. That's what I'm trying to think of. Compliance.
Simply Sure says,
MacOS maybe? Thoughts?
It depends. I would start with the compliance. I don't know anything about managing Mac OS on a network. Okay, cool. Let's go back over the training stuff.
Mad Max Voltro says,
You'll try, and I was thinking it needs to support 5 layers at a time with good speeds, but should I use a Unity VPN to connect to it, or just
Yes.
use port forwarding for the services?
VPN.
Loaf says,
The most secure OS is going to be the one that's not connected to the internet.
Yeah, there's that. Yep. That's a good point. That's a good point.
Mad Max Voltro says,
Is open secure enough? It's the only I'm familiar with.
I don't know. You're gonna have to do some legwork on that and take a look at some VPNs. If it's a law firm, like, do they have a budget for what you're doing? But there's plenty of VPNs out there to choose from. I don't have a suggestion for you.
Loaf says,
Give them 2 systems each, one internal only network, no connection to the internet. and the other with access to the internet for public browsing only tone.
Mad Max Voltrosis.
Yay 1.5K.
Loaf says.
1.5K XT.
That's it.
Translated from Spanish.
Feels a little light.
Mad Max Voltrosis.
But I also need to buy server with that.
Hack the Planet says.
Even more secure. 2-person integrity inside of a sealed room with guarded perimeter access where each person has half of a credential. D.
Loaf says.
So you're only getting them a pen and paper each for that, and maybe a filing cabinet. Yeah, you're being conned by naivety. I'd be sending them packing if they're trying to hire you.
Yeah, Mad Max Voltron, you are chatting with two sysadmins, people familiar with building out infrastructure like that. So I don't know if you're trying to help the law firm, but it feels like they're taking advantage of you based on your experience. Not trying to be mean about it, just trying to have you understand what's going on.
No one gets security for 1.5K.
Mad Max Voltrosis.
What budget for the would you suggest for creating it?
Loaf says.
Those are loaded
If
questions.
a law firm only has a budget of 1.5K, they're not a very successful law firm.
Like that's like you're asking the right questions, but you are Twitch chat may not be the best place for those answers. Not because you wouldn't get good answers from the people that are in here right now, but there's just so much context around what you're asking. It's good that you're asking the questions again, but there's so much context around it. I bet Loaf and Tagore are up to it.
Mad
but
Max Voltrosis.
I just trust you guys.
Hack the Planet says.
Another way to approach the problem. What security solutions could I present given that the customer's budget is only 1.5K?
that's a good one. Excuse me.
Loaf says.
Anything you're getting to facilitate 5 people doing anything for that price, you're going to be getting secondhand, and you couldn't trust the security of that.
Yep. Yeah, good questions, Mad Max. Okay, I think we're still here. I didn't finish up this one. No, I didn't. Oh wait, it was already there.
Let me ask you a question. What do you think?
I don't know how it is in the USA right now, but we could barely get 1 to 2 computers for that price.
Hack the Planet says.
Yeah.
Think about it like this. No matter what budget you throw at security, it's never going to be enough. So 1.5K is better than nothing.
Okay, yeah, that's
Mad
one way to
Max
look at it.
Voltrosis.
But I'm saying I'm not likely to be targeted. BC, the law firm only does like children cases if I what I mean.
I hear you, but everyone, everyone's a target. I mean, there's going to be different levels of risks depending on what you do, but I don't think you should look at it as if you're a target or not. I think the best way is you should take the advice Tagore and Loaf has given you and start with the budget that they have. If it's $1,500, and see what solutions are out there that you can deploy for $1,500. What solution or combination of solutions for $1,500?
Loaf says.
Saying that you're not likely to be targeted is 100% naivety.
Mad Max Voltrosis.
But yay.
Loaf says.
Attackers don't care who you are or what your company does. If they find a way in, they're going to find a way to extort money out of the company.
Yeah. Excuse me.
Hack the Planet says.
If you ask me, I'd start with firewalls, network segmentation, and authentication. You can probably get that kind of setup for 1.5K equipment cost plus labor.
Now remember, our goal is to transfer transport data from host A to host B.
Loaf says.
Now, before that can happen,
Do they
some
already
information
have
must
any
be
computers,
added to the data.
devices,
The term
servers?
we use for this added
Mad Max
information
Voltro
is
says.
encapsulation.
What budget should
There's
I
certain
ask if
information
you were
that must
me?
be added to
I thought
forward the data to the next
1.5k
hop
would be enough for
in the forwarding
basic
path.
startup.
Some
Loaf
information that must be
says.
added about the ultimate
Surely this is
destination,
an A from
device,
scratch setup.
and the actual destination application. Let's learn more about how this works. Look, you may not believe me, but we used to actually take our data and write it on a piece of paper. Then we would put it inside of an envelope and add some addressing information so our data could be transported to the correct destination. Well, in modern times, what do? We take that same data and we store it in memory on the computer. But how does that data get addressed and formatted so it can be transmitted to a remote destination?
Hack the Planet says.
It's hard when working for a customer who has no idea what their requirements are, so you have to make up some minimal requirements, then work backward from requirements to solutions, then to cost.
Some real knowledge bombs in here, Mad Max. I hope you are like taking notes. Like there's a lot to unpack here.
Let's see how this works. So back to our old world analogy, I have my letter written. I
Loaf
have just
says.
laid my pen down on it.
Agreed. Find out what they have in totality. Figure out what can be done to improve what they already have. $0 cost other than labor.
Rifling through my desk looking for an envelope. Well, today what I've really done is I'm about to hit send on that email. It's ready to go. But this data must be addressed and prepared for transport. So let's look at the magic of encapsulation.
Loaf says.
Then evaluate its current state, and what could be improved with additional hardware, and have them prioritize the cost, benefit.
Hack the Planet says.
And in terms of contract work, set requirements in stone prior to beginning a project, then lock in costs once the customer agrees with the proposed solution and costs. Don't deviate from requirements once you've met their acceptance criteria.
Loaf says.
Is a 1.5k a monthly commitment, or a one-off?
What keeps flipping over here?
USD?
Mad Max Voltro says.
Not a euro.
Translated from Indonesian.
There are typically 3 layers of encapsulation that are added to data for transport. The first layer is called the transport layer. This layer identifies the applications that are generating the data. The next layer, the network layer, identifies the addresses of the devices that are running the applications that are generating the data. And the final layer of encapsulation, the data link layer or the Ethernet
Hack the
layer in
Planet
our case,
says.
contains
That's a rough
the
cage to be
network
locked into.
address of
I don't envy
the
you.
device that's
D.
generating the data and the address of the device that is
Warlord
the
Killer
next hop
028
in the
says.
forwarding path for the
Is
data.
Juniper Networks
Let's take a deeper
simulation?
look at
I should
these
check
layers.
it.
Juniper is the hardware that I'm going to try to simulate. GNS3 is for network simulation. That's what's going on in the background.
Loaf says.
I'd be throwing them on Exchange Online for email. Comes with OneDrive storage and is easy to set up. It can be configured with data locality to keep it in or near your country, region. If there's budget left over, Azure has data loss prevention that can be configured.
The first
Hack the Planet says.
They don't trust.
Yay, honestly, I'd go cloud with that budget, since you get a lot of security taken care of for you with cloud providers. CapEx isn't an option with 1.5K.
Trust it. That's the thing. They don't trust it. They don't trust what? They don't trust Exchange Online. And some of the high staff people say those will be more often breached than ours, the cloud servers. Oof.
layer of encapsulation, the transport layer, identifies the applications. The first layer of encapsulation, the transport layer, identifies the applications on the hosts that are generating the data. When an application launches on a device, it is a
Mad Max Voltro says.
number.
Alright,
And the
I got
port
my
number of
notes.
the
You'll give them
applications
some
that are
arguments. Thanks, guys. This really helped.
Hope it did, Mad Max. Good luck.
Where I go, it's hard to find the perfect places. Need to
Communicating this data are included in the network layer. So when the data arrives at the destination host, that destination host can determine, oh, this is data for this application. For example, your email client or your web browser. And when the remote host replies, it knows exactly the port number of the application on the remote host to reply back to. There is some additional important information that is encapsulated at this layer. The first layer of encapsulation, the transport layer, identifies the applications on the hosts that are generating the data. When an application launches on a device, it is assigned a unique port number. And the port number of the applications that are communicating this data are included in the network layer. So when the data arrives at the destination host, that destination host can determine, oh, this is data for this application. For example, your email
Hack the
client or your
Planet
web
says.
browser.
Yay, I'd price a basic on-prem infrastructure for them as an option with true costs which will go way beyond what they're willing to pay. Then I'd price the monthly cloud solution for them.
And when the remote host applies, it knows exactly the port number of the application on the remote host to reply back to. There is some additional important information that is encapsulated at this layer. Let's take a look.
Always getting overexcited. I know I said I needed the love, but I don't think that you
Mad Max Voltro says.
Or tie.
There are two primary protocols that operate at the transport layer. One of them is called the Transmission Control Protocol, or TCP. TCP enables an application to verify that the data that was transported to the remote host was received. You see, TCP can include sequence numbers in the packets as it's performing encapsulation. When the packets arrive at the remote destination, the remote host can reply back that I have received data with these sequence numbers. So the source device can determine the data that I sent was received. Another key benefit of including these sequence numbers is if any of the data did not arrive at the remote host, it can request the missing data by requesting just the packets that include these specific sequence numbers. The entire file does not have to be transported again, just the missing pieces of data. This helps make network data transport more efficient. Now there's another protocol at the transport layer called the User Datagram Protocol, or UDP. There's certain types of data that I really don't need to guarantee delivered. And I think about data for streaming applications. I'm streaming audio and video.
Mad Max Voltro
It's going pretty
says.
quickly, my audio and my
I
video
gotta go,
stream.
thanks you
And I
all.
don't really care if every single packet
Sounds good, Mad Max. Have a good day. Good luck.
in the video. Counting these packets and acknowledging the delivery would slow this process down and make the applications not work very well. The applications will actually decide whether or not the data needs to be guaranteed for delivery and request the correct protocol be used for encapsulation at this layer. Once the transport
I need to
encapsulation,
get back to coffee.
the network layer encapsulation is performed. The network encapsulation includes the source and destination IP addresses of the devices that are generating this data for transport. The transport devices, like the routers, will analyze this layer of encapsulation to discover the destination IP address for this data and to determine the forwarding path to transport it to the ultimate destination device. There is some additional information that is included at the network layer header, but for now, if you can remember that the source and destination IP addresses of the devices that are generating this data are included here, and this data is important for transporting the data from the source all the way to the destination device.
Hack the Planet says.
Going to look at a house
Layer of
around 2 p.m.
encapsulation,
today.
the data link layer.
What? You just got into it. Whatever. Why?
Loaf says.
Mad to me that they don't trust the security of a billion-dollar company, but they think 1.5K can get them something good.
Right.
Hack the Planet says.
I signed the lease for this apartment a year ago. D.
Keep on moving. Whatever works for you.
John says. Neovamisbist says.
Trying to remove a couch after it's been in the house like 10 years. Can't seem to figure how to get it through the door frame, lol.
Pivot. Pivot. Or take it apart. I've dismantled. Yeah.
Loaf says.
Remove the window, smile, smile.
I've dismantled couches. I'm like, how
John
bad?
says.
How bad do we
Neovamisbist
want?
says.
How bad do we want
It's a
this
reclining
couch?
3-seat leather and only me doing it, lol. I took the door off.
That's tough, man. That's tough.
Hack the Planet says.
Why? Mostly because I don't have enough room for my kitchen stuff in this apartment. I still have stuff on the counter and in boxes from when I moved in.
John
All right.
says.
Yeah. If you need more
Neovamisbist
room,
says.
man.
Was thinking saw.
Yeah. Yeah. If you don't need it. Yeah. If you don't need it, who cares if it comes out in pieces? Yeah. And if you need more room, you need more room, Tigora. I hear you.
The final layer of encapsulation, the data link layer, includes the source address of the device that's generating the data and the destination address of the device that is the next hop in the forwarding path. The addresses that are encapsulated at this layer are changed at each hop in the forwarding path. There is also some data integrity information that is included at the end of the data. This data is used to verify that the data has not been interrupted in transit.
Hack the Planet says,
There are some
That and
terms
it'd
that are
be
used
nice to build
refer
equity or
this
have a
type of
home that
data
can be paid off
encapsulation.
by the time I
The
retire.
layers that are added
If
to
I
the
live that
front
long.
of the
Stop it.
D.
are called headers. Anything added to the end
Loaf
of the data
says,
is called a trailer.
So many
That's
bunnies
all
in
I
our
have to say. That's
networks
pretty
moving the
simple. We
packets
can remember
around.
that. So
Hops
in our
everywhere.
Hops everywhere.
and a single trailer. There are some terms that are used to refer to this type of data encapsulation. The layers that are added to the front of the data are called headers. Anything added to the end of the data is
Hack
called
the
a trailer.
Planet says,
That's all I have.
I'm no boo-hooing, but anyone can get hit by a bus. D.
Right. Excuse me. Sorry.
To say. That's
Fighting
pretty
it.
simple. We can remember that. So in our example here, the data has 3 headers and a single. Let me ask you a question. What do you think happens when the data arrives at the destination?
I'm going with data de-encapsulation. Oh, a little timer.
If you answered de-encapsulation, you are correct. The destination device examines the data link header to determine if the destination MAC address matches the inbound interface. If it does, the frame checks some sequence
MAC address, IP addresses. What was the first one? Oh, ports.
is validated to determine that the data was not
The real
corrupted in
solution
transit.
there is to
If
stop
everything
walking out
checks
into traffic when a bus is
the data
barreling
link
down the
header is
road.
removed,
But you know,
and the remaining
life's
data
hard.
is forwarded to the layer 3 software for processing. Layer 3 processing includes determining if the destination IP address in the layer 3 header matches the IP address configured on the inbound interface. If these values match, the network layer header can be removed and the remaining data could be forwarded up to the transport layer software for further processing. Transport layer processing includes examining the transport header and determining the destination port.
Destination ports.
Once this has been determined, the transport header can be removed, and now the data is delivered to the destination application on that device. In this example, host A has
John
all of the
says
data that it would
Neovimus
like to
Biscuit
send to
says,
host B packaged up
need a
and
break
ready to
roll.
be
I
transmitted.
muscled it out.
Yes. Square peg, round hole. Oh. Old man noises.
Hack the Planet says,
I used to teach this in a way that people never forget. I'll have to go through OC layers with you later.
John says Neovimispist says,
Of course now they are in backyard and I have to figure how to dispose of.
Gasoline and a match. You're out there in the sticks. Start a bonfire. The biggest problem with me retaining the OSI
That's not
like
environmentally friendly.
model and like its utility out of it. Like I don't have. I mean, I deal with IP addresses, I see MAC addresses, ports and services and that kind of thing. So I mean that helps, but like actual utility, getting utility out of it, not much.
Especially during wildfires time.
Well, it's so effing wet down here. Like, I don't know about you up there, but it's been so wet. I don't think anything's catching on fire. But you're right.
Host A has all of the data that it would like.
Who's that? Julian120. Thanks for the follow.
John
How you doing
says
today?
Neovimispist says,
By the way,
Pretty dry up here.
can I say how much I love this little thing? I figured out how to like move it around. I love it. It's so simple. Where's that? Right here. So simple, but I love it.
To send host B packaged up and ready to be transmitted on the
120
network.
says,
But what
Hi,
happens
how's
next?
it going?
Great, Julian. Great. How about you? What are you up to today? How'd you find us? Thanks for flipping through the Twitch channels and stopping here.
Are all messages TTS?
Yeah, they are. It helps me instead of reading them. It helps me interact with chat better than reading them. If you want to not have your message read, just put a dash in front of it.
Yeah, from recommended.
Cool.
Host A has all of the data that it would like to send to host B packaged up and ready to be transmitted on the network. But what happens next? How does host A actually transmit the data that it wants to send onto the wire? Let's take a look.
We gotta go back.
The cables that a device uses to connect.
Juliank
In
120
this example,
says,
host A has all.
Hi. Usually I have to give bits to have my messages read. Embarrassed smiley face emoji.
I don't know. I've thought about that. I can turn them. I can turn things off and on, but I just think that's silly. Isn't the streamer supposed to interact with chat? So to prioritize certain messages over, I don't know. Whatever. It'll become a problem when the channel gets bigger, but not a problem now, Julian. I hope you enjoy it.
Is this course for professional development?
Good question. It is. It's for a potential job that I'm going after, a potential job I'm pursuing.
The data that it would like to. In this example, host A has all of the data that it would like to send to host B packaged up and ready to be transmitted on the network. But what happens
My
next?
new brain says,
How does host A
Hello.
Hello, my new brain. How are you? Welcome back.
Groovy. Just working a MySQL course.
Oh, you have a MySQL course? Is it for creating and updating and maintaining MySQL databases, or is it tell us about it? This is a little bit about me.
It's for university.
Juliank 120 says,
Do you know if there's any particular rules about streaming course content? I'd love to watch more of them, but I just wonder if it goes against someone's dose.
It depends. It depends. Usually you'd catch me streaming like Try Hack Me or Hack the Box. There's certain rules around what I'm allowed to do for each of those. We're rolling the dice on Juniper Networks. I don't know what I'm allowed or not allowed to do. It's free content, so I'm thinking I'm allowed to stream it. Each platform is specific, so just I would, if they have a frequently asked questions, I would check that out, or I would message them directly.
In this example, host A has all of the data that it would like to
Juliank
send to host B
120
packaged up and
says,
ready to be transmitted
Free
on the
content.
network.
Sounds fair, haha.
Next, how does host A actually transmit the data onto the wire? Let's take a look. The cables that a device uses to connect to your Ethernet network determine how it's able to transmit data. If a device on your network connects using a copper Ethernet cable, then the network interface card on that connected device can transmit pulses of electricity over that copper wire, and those pulses of electricity can be used to signal data. A device connecting to your Ethernet network using a fiber optic cable has a network interface card that contains a laser, and that laser can be used to send pulses of light.
Sorry, a laser. This guy. He missed a golden opportunity there.
Data. Connecting to your Ethernet network using a fiber optic cable has a network interface card that contains a laser, and that laser can be used to send pulses of light. Through the fiber optic cable, and those pulses of light can be used to signal
Sharks with
or
freaking
transmit
lasers?
data. Let's look at how the data is formatted. Before host A can transmit data onto the wire, the data must be converted to binary format. Binary format is a way to represent any type of data that a device would like to transmit on the network as a collection of ones and zeros. It's very easy for a device to signal ones and zeros onto a network
120 says,
I'm a laser. I laze a lot.
by adjusting voltages in a wire or by turning a laser in a fiber optic interface on and off. Let's look a little bit closer at how this works. When I was a kid, on Saturday mornings after the cartoons went off, there was either a war movie or a Western movie, or at some point in the movie there was a critical moment where we needed to immediately communicate an urgent message to some faraway location. And at the time, the only way to do that was using a telegraph machine. So we'd run into the radio operator's room, urgent message, urgent, please communicate this to this location. And the radio operator could convert that handwritten message into Morse code. Do you remember that? They had converted every letter of the alphabet, every number, into a combination of dots and dashes. And so the radio operator could use the telegraph machine.
Are you familiar with this content already based on experience or previous studies?
I am familiar with, not experience, but previous studies. My experience with this particular information is through pen testing. So services and the ports that they're running on a network. The IP addresses and MAC addresses of those devices.
Used to make contact, and making contact would generate a tone on that wire that could be transmitted a long distance. So dot dot dash dee 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 dot dot dash. You remember that? Not a whole lot has changed since the 19th century. We are still able to go dot dot dash, but instead, remember, we convert our data to binary. A collection of ones and zeros. Hey, that's just two little toggles there. So it should be pretty easy then to signal a change of voltage, for example, or a change in light off on a signal. So for example, maybe when the light comes on that fiber optic cable, that signals a 1. If the light stays on, it's a stream of ones. If the light goes off, we change to 0, and we go zeros until the light comes on again, and that means a 1.
Okay.
We can adjust the voltage in the wire of a copper cable. But either way, it's still just like Morse code was back in the movies. Dot dot dash 101111. And we use pulses of electricity or pulses of light to signal that data.
Loaf says,
Can't believe they're talking about Morse code as if all modern kids learning this stuff would know what that is.
Right. Yep. That's one way to look at it, I guess. But I think you could accomplish the same thing just like with maybe just a light switch.
Literally, a light switch is so much more accessible to most people.
They obviously didn't consult us when they put this together, Loaf. I hear ya. Juniper, Loaf and I are available as consults. I'm just saying.
What has changed over the years is how fast those ones and zeros can be transmitted on the wire. Now, it's measured in bits per second, but if you can imagine a device transmitting at 1 bit per second, that means 1 bit per second. 1 or 0 per second. Pretty slow. Kilobits per second. I can do 1,000 ones and zeros. Can you try to say 1,000 ones and zeros in 1 second? Your networking card can. 1 megabit per second? Okay, come on. You can do it. 1,000,000 ones and zeros per second. Ready, set, go. How about 1 billion bits per second? And you know it keeps getting faster and faster and faster. And that's what amazes me, is how we can adjust voltages in a copper wire or pulses of light in a fiber optic cable that rapidly to signal ones and zeros that quickly across the network.
Okay. I've used these terms before, but I've never really have thought them through and thought them out. I just always knew that, you know, 1 bit per second is going to be slower than 1 gigabit per second or megabit per second. So this is useful to me. That's hilarious. That the first modems were kbps. No wonder why that shit was so slow. No wonder why that shit was so slow. Dial-up, that was our first dial-up modem, was kbps. So 1,000 ones or zeros. Megabits a million. Okay, cool.
I may have mentioned it before, but my friend got broadband before anyone else I knew. They regularly disconnected my dial-up by DOCing my connection. Which, as you can imagine, 1 MB/s versus 56 kilobits per second doesn't take much.
Nothing. That's interesting. Good morning, Stone.
Stone says.
Good morning, all.
John says Neovinisbus says.
I had a really cool dial-up modem that had 2 Ethernet ports on it. Went to a switch and I had multiple computers on the network on dial-up. Then I went a step further and hooked Wi-Fi up.
Look out. It has never been the same.
X Hay says.
I learned Morse code for fun.
Whatever.
Don't judge me.
I'm judging you. Whatever. It's cool.
We saw in this module that on an Ethernet network, we can transmit
Planet
ones
says.
That's a common misconception about modems. 28.8 and 56K were baud rates, not bit rates.
John says Neovinisbus
All right.
says.
I remember
I
playing
don't know what the
WoW on
difference is.
dial-up.
What's baud versus bit?
X Hay says.
Google response, baud refers to the number of signal changes per second, while BPS measures the number of bits, zeros and ones, transmitted per second.
Hack the Planet says.
Baud was a measure of signal frequency, not how fast the data would travel down the path.
Nick says.
Refreshing my lurk, brother.
Right on.
Much love, Theo.
Thanks, Nick. Hey, did you know that Nick is a DM for a Dungeons and Dragons campaign that I'm currently in? We did the first episode. We're editing it for YouTube. It should be out soon. Thanks for the shout out, Spectre.
John says Neovinisbus says.
Fullbow frog.
Stone says.
56K models were kbps.
John says Neovermispist says.
You're in it again? Are you gonna get killed off right away again?
I didn't get killed off right
XA
away.
says.
I had to get killed off right away.
Are we getting a critical role refresh?
John says Neovermispist says.
Lol lol lol.
Translated from Haitian Creole.
They did kill me off though, which was awesome. Because because like the job I got, I couldn't do it during the week. Nick is great. I think Nick's a great creative on the fly dungeon master. So it's getting cut up for YouTube right now. So we'll let you know when it's out, but I don't see any reason why it won't do well. So I'm understanding bit and bod, but I'm having a hard time. Like, how far off can the changes happen? You know, how far off is the discrepancy, the fluctuation between each one? If bitrate is the 1 per second, flipping from 1 to 0. Oh, wait a minute. So if you have 1 1 1 1. Like 1110, you would get faster speeds out of baud, if I'm understanding it right.
These blue skies in your eyes, I'll never see again. These blue
Hack the Planet says.
Most 56K modems were 56 kilobits per second down and 33.6 kilobits per second down, even though the 56K was technically a measure of baud rate.
Loaf says.
From what I'm reading, a 56K modem had a baud rate of 8,000. 56K was the speed, not the baud.
Hack the Planet says.
Sorry, 33.6 up.
left me in blues.
Okay.
Zeros
John
using
says
both copper
Neovermispist
and
says.
fiber optic cables.
Pepperidge Farm remembers.
More about cable types, connectors, and port speeds in another module in this course.
Okay, I gotta take a quick break. I gotta go to the bathroom, and then we're gonna stand up for a bit. What are we on? The layered model.
X Hay says.
So a 2,400 baud would be 9,600 basis points max?
Hack the Planet says.
That's probably right, maybe I'm spewing BS.
X Hay says.
4-bit.
Loaf says.
Web link.
Be right back.
X Hay says.
Our one in the books. 19 more to go.
You can't see him. He's right there. The good boy.
Wise Stone says.
This makes me want to start my CCNP studies back up.
Hack the Planet says.
An interesting conversation about analog circuits that has little to no bearing on present-day networking. D.
Wise Stone says.
I use baud rates every time I use a console connection to a device.
X Hay says.
Cisco. The most fun CLI experience with an OC model.
Everybody got a line, it's time to cross it. I've never seen so many people ain't believing themselves. You only got one life, time to make it right. Somewhere far away, there is a place where we could disappear. Wanna go to places I've never seen before.
Hack the Planet says.
Yay, serial connections is really the only place you see baud now, and it's usually either 9,600 or 115,200. Haven't really see baud rates other than that.
Wise Stone says.
Yeah, those are the most common that I use as well.
Growing apart, further away. We're not how we used to be, making it worse with every word. We said some things we didn't mean. Words can hurt, love can.
Hack the Planet says.
It's been 40 years, still wondering when we're officially going to stop teaching the OC reference model. D.
I hope you never forget. You mean the world to me.
Wise Stone says.
Never, it's still a great breakdown over the TCP IP model.
To me.
Wireshark still breaks down by OC layer.
I've always wanted you beside me. Since you came, I found myself. We're gonna fix this, whatever it takes. No giving up till.
Hack the Planet says.
Really? I thought it used TCP IP5 layer.
The only way to learn is by playing. The only way to win is by learning, and the only way to begin is by beginning.
Like saying, what are you talking about? 1 hour in the books? 19 more to go?
Nothing in this world that's worth having comes easy.
I really had to go to the bathroom. It was close. Miss Theo just got home. She had to talk to me. I was doing the little kid dance. It was close. I'm standing up now, so.
Wise Stone says.
Always fun.
So we're still going on vacation while this is all going on. So you're all going to have to tell me what kind of stream that you want for vacation. I usually do one.
John says Neovamispist says.
Did you do the PP dance?
Loaf says.
Dino dance.
We've been, yeah, that's what it looked like, actually. That little dino, that's what it looked like.
Hack the Planet says.
Hot tub time machine stream.
Data has multiple headers added to it, and we talked about the term encapsulation. Each of these headers is associated with a layer. You'll hear, what network layer is this happening at, right? Is it layer 1, which has always been the physical layer, right? Do you have to plug the cable in every time? There are certain actions that are performed when we perform layer 2 encapsulation, and there's software on a computer that performs those functions. There's actions that are performed to create the layer 3 header, and there's separate software that performs those functions. And the same thing with the layer 4 headers that are added to data as we perform encapsulation. The processing of each of those layers is actually done by separate pieces of software. You see, this is designed to be very modular, so modifications can be performed with layer 3 software that don't affect layer 4 or layer 2. So it's really easy to update and plug and play with these different pieces of software as networks evolve over time.
I feel like this diagram is like backwards and upside down. They're not necessarily calling it OSCP, but I mean it is. So I would feel like this is the ones and zeros, the ups and downs, the right, the signal and no signal. I feel like it should be up here.
Loaf says.
Axis.
Translated from Slovenian. Wise Stone says.
Correct.
Hack the Planet says.
Turn it sideways, then turn your head sideways. It might make more sense.
Loaf says.
OSCP is stuck in your brain. XD.
Maybe. Anyways, I don't think I'm going to get too hung up on it until they like slap OSI up here and physical network and transport and all that other stuff.
Crispy0x says.
Hey, Crispy.
I just bought premium on THM. Do you recommend it?
Crispy,
Magic
it feels like
says.
that's a question you should
Future
ask
man.
before you bought it. Yeah. I mean, how long did you buy for? A month? You should get a lot of utility out of that. I think you get a lot of utility out of that. Oh, you bought it for a year. Well, you better get your money's worth out of it. How are you going to get your money's worth out of it? Magic user, welcome back. Good to see you.
Crispy0x says.
1 year. It was on discount.
Okay.
I'm thinking on taking the path.
There's like 5 different paths. So you're thinking about taking a path. Whatever it is, get your money's worth out of it. Cool.
System engineer.
Good. Yeah. Whatever it is, you need to just get your money's worth out of it. So do you have a consistent study schedule for yourself every day or every week?
Wystone says.
They dropped yearly to be about $6 or $7 per month.
Loaf says.
I think you can get a heck of a lot done on THM without premium.
Me too.
But if you've got premium, focus only on the boxes that require.
Hey, that's smart. Yep, that's great. That's a great suggestion.
Hack the Planet says.
When I used to teach the OC model, I'd have students map a table with the following. 1. OC layer name 2. Physical equipment at that layer 3. Type of addressing used 4. Name of the units used at that layer.
I like that. Yeah, no, Loaf wasn't arguing with you, Crispy. Loaf was saying, giving you a suggestion. And if Path is a premium feature, then great. Then use the shit out of it. That was a follow. UG, thank you for the follow.
Christy0x says.
How you doing today,
I
UG?
kind of like to be guided, as they think what is important to learn.
Loaf says.
What I'm saying is, that in order to get the most value out of your premium, only focus on the content that costs money.
UG0908 says.
I'm good.
Welcome to the stream. Thanks for popping in chat. How did you find us?
UG0908 says.
Search Linux.
You searched Linux and that's how you found us? On Twitch. Whoops, sorry. Cool. So the little tag works. That's good to know.
Yup.
Well, let us know if you have any questions. What are you working on today?
There are more layers, and there is more processing that is done before the data is transmitted on
Learning
the network.
Linux.
Layer 7's a big one. That's always the application.
This doesn't make sense to me. There's at the data link layer, there's already that many encapsulations in front of it. I thought it was like the other way around.
Hack the Planet says.
Yay, protocols are good to map on after. I'd kind of start with the basics there and start to layer on protocols afterwards.
Wystone says.
You add more as you go down.
Loaf says.
It's like passing a parcel Theo. Each layer down you go, you add a layer of wrapping. That's encapsulation.
Wystone says. Loaf says.
Each layer up you go, you take a layer off.
Hack the Planet says.
Russian nesting doll concept.
Right. I hear you, but I feel like I got to make this make sense. So I got to stop here and talk through this. So in this model, it doesn't matter, actually. It just is what it is, right? So if you're traversing down, like from the application layer.
Dayloop says.
Physical layer go BEEPBOOP.
Hey,
Sparkles
Dayloop.
emoji. Tomato emoji. Sparkles emoji.
Thank you for the sparkles,
Loaf
Twino
says.
Sparkles.
Each layer only cares about its own little bit of data, and it passes on the rest.
Anytime I've thought about this, I've always thought about like a computer being up here and a computer being down here. But I don't think that's right. So that's why I'm having a hard time with this.
Technically layer 2 is the only one that both appends and prepends. Everything upwards of layer 2 just adds headers.
Loaf says.
Double that chart and flip it on its head.
Yeah, but not double it like 1, 2, 3, 4. Double it like 1, 2, 3, 4, application layer, 4, 3, 2, 1. Double the chart and flip it on its head.
Hack the Planet says.
More like this. Web link.
Dayloop says.
You gotta use a wire to connect to another computer.
Thank you, Dayloop. Thank you. I was fuzzy on that, but thank you very much.
Loaf says.
Web link.
Stone says.
Not true. Wireless transmissions still count under physical smile.
Loaf says.
Picture of someone from USA chatting with someone from Australia. Smile.
Hack the Planet says.
I used to use line of sight radio signals, but honestly, any media will do.
Dayloop says.
The only thing a wire can work with is physical layer.
Right. Okay.
Stone says.
There you go. That's a good representation.
So, okay, I'm thinking of this as too linear. No, not too linear.
Hack the Planet says.
Yay, that's the conceptual mapping. But the only thing really traveling over the wire is a bit stream.
And this is the same thing, but instead of them stacked, it goes down and then I can't think of it as down and back up. Sender is using application, presentation, session, data stream. Okay, I don't know what all these arrows over this way mean.
You can absolutely think of it as down and back up.
My New Brain says.
Maybe download/upload?
Smetric says.
Maybe sending and receiving. A good day.
Translated from
Morning,
German.
Symmetrics.
My New Brain says. Loaf says.
That's a good one.
I've always thought of it as starting at the physical level. And that may not necessarily be accurate. It feels like looking at these things, it's starting from an application.
Smetric says.
And working its
What are you
way
trying to understand?
down and then works its way back up to the application.
Yeah, you need a physical medium for everything to send across. On top of that, you need some kind of link. Ethernet or Wi-Fi or laser light and receiver.
We could go wherever
And that's why it's
David
from the
says-
viewpoint of the sender.
You can also use years of information control and mass manipulation to finally control the footfall traffic at a major intersection over a 3-hour period to send a message.
Metric says.
Then you need to figure out how to get those to be grouped together so they're not all randomly talking to everyone everywhere. Network.
Hack the Planet says.
When transmitting from your computer, networking decides how much gets sent per packet, the maximum transmission unit or MTU. Then the data is split into segments that get encapsulated on its way to the wire. When it gets to the remote side of the network connection, de-encapsulation reassembles the segments back into the unit of data you started with.
Metric says.
Then you need to figure out a way to group the chunks of data.
Okay,
Header/data payload.
I gotcha. But I'm at a very more basic understanding. I've seen this model before tons of times, but
YAME 2 is defaulted to 1500 on Windows 0. You can abuse this and tweak certain apps equals.
thank you for that. But too far out of scope for what I'm trying to understand right now. So this is good. This is good. This helps me more. Like I said, I've always thought of it as starting at the physical layer, but that's not really what it is. I mean, when they explain it to help you understand it, I guess I understand why they start with the physical layer. But
Hack the Planet says.
And let's not even talk about jumbo frames. D.
applications. So both. Typically, you're starting with the application, presentation, session layers.
Loaf says.
Everything starts at a physical layer if you're not considering networking. It's all electrons and silicon.
John says. Neovermispist says.
Scope Dzen. Oh wait.
Okay, and transport layer is going to be segment frame.
Metric says.
Jumbo frames aka anime frames? It's over 9,000. Bar DMCHHH.
Data link is going to be
Stone says.
Transport layer is your delivery style. Are you tracking the package or yeeting it?
TCP or UDP.
Metric says.
Network is IPs,
TCP or
IP
UDP.
addresses, and then data link is MAC addresses.
UDP equals yeet.
Translated from Indonesian. John says. Neovermispist says.
Jumbotron.
Stone says.
Correct.
Right, that makes sense. That makes sense. Here, I got all this information. I got whatever I'm trying to send. Excuse me. The sender needs to know the port it's going to first. And then from there, it needs to know the IP address. And then from there, it requires the MAC address.
Metric says.
What can you assume about UDP by its very nature?
Some shit's going to be dropped. It's not stopping.
Potentially insecure.
I guess. I'm not overly concerned with that right now.
And thus no financial shit should ever use it.
Imagine monitoring. Is there a way you can pick up those
Or
drop
any
packets?
mission critical shit that requires reliable communication.
I'm going to save this.
If it's Wi-Fi, yes. Pretty damn easily, lol. Lol. Okay, so Therese, this shit quick. Quick. Quick UDP connections that kinda suggest the opposite of what I said. Lamau.
Translated from Haitian Creole. Loaf says,
Where am I going to put this?
TLS 1.3 encrypted by default over UDP.
Let me just put it in Juniper real quick. Do I have networking? Do I just have plain networking? I feel like I have networking somewhere.
Symmetric says,
Less than. Hasn't been keeping up with TLS. Or shit in general really for the past 5 years lol. So I'm operating completely out of date, FML.
Loaf says,
We sent you all the info with UDP packets. Didn't you get them?
Symmetric says,
Imagine building a TCP of sorts out a UDP just for the reduced overhead and speed gains.
Hands itchy.
Wonder if anyone did cost analysis of TCP versus UDP and the hardware associated with it all. Like electrical usage cost.
Wisestone says,
I'm sure there's a few studies out there.
Data, right? That's what we want to transport across the network to some destination. Layer 5 and 6 deal a little bit with some data translation and some session establishment, but you don't really deal with those too much, especially when you're trying to perform network troubleshooting. You will spend a lot of time troubleshooting layers 1, 2, 3, and 4 in your networking career. As I mentioned previously, there are certain layers here that you'll spend more time on as you manage a network and perform network troubleshooting. For example, data at layer 7 and the headers at layer 4, layer 3, and layer 2 contain information that a security device like a firewall can use to determine what action is taken when packets that contain this matching information arrive. Is this traffic permitted to be forwarded? Should it be logged, counted, encrypted, or discarded? Understanding how these layers are added and what type of information is stored in these headers will help you manage and secure your network in the future. I promise you that you're going to solve a lot of networking problems in your career by validating layer 1. Every device has to connect to the network before they can send and receive data. So you may have a device that had a network cable perfectly connected yesterday, but last night somebody was in the data center and knocked a couple cables around, and all of a sudden nobody can send and receive any email. And before you do a lot of very advanced troubleshooting, it might help just to walk down to the data center and make sure it's actually plugged in.
You walk down to the data center, buddy.
This might be a little bit confusing, but each layer is really independent of every other layer, and so there's
Symmetric
different
says.
names used.
Walk down or call DC knock.
To label data that has a certain amount of encapsulation on it. So, for example, data is data. Okay, I'm good there. But data with the
Say
layer
I need
4
handle on my
transport header
VM in rack
information added at that
420
point.
server 69.
Symmetric says.
Visual check SFP Plaza KTHX.
Quit making up acronyms, Isometrics.
It's called a segment. There you have it. Now look, when we add the layer 3 header on there, the IP header, at that point, when it's got the layer 3 and the layer 4
LMFAO,
header
nothing
and the
made up
data all
lol.
glued together, they call that now a packet. And when you get the layer 2
Okay, I've seen this before.
on there, at that point, that data is called a frame. Okay, so different terms are used to identify what layers have been added to your data. And when it all comes down to it, and that data is actually transmitted on the network, be it wirelessly or on the wire, remember, it's converted down to little bitty old bits, just little bitty ones and zeros that are pulsed and flashed onto the network.
Ystone says.
I've got about 20 Cisco 10 FSM SFPs in my work bag. Those things are expensive.
Loaf says.
I was reviewing my switch data the other day and saw a client connected at 10 MB/s. I went to the end user's desk and the clip had snapped off their Ethernet cable. Rather than tell me so I could replace it, they used blue tack to hold the cable in. Obviously all the pins weren't making contact.
Ystone says.
Blue tack, that little
10M.
sticky stuff, just
Translated
jammed onto
from
the back
Italian.
of it. That's awesome.
10G.
Symmetric says.
DC knock equals data center network
I know,
operations center
I'm
handle
fucking
equals
with
hands
you.
and eyes,
Oh my
SFP
God.
equals small form factor pluggable plaza equals please THX equals thanks.
Loaf says.
Yup, absolutely mounted it up to hold it in.
That's awesome.
XD.
Symmetric says.
I won't say I've used Jbwell to fix a cable smile.
JB Weld,
Life
that's
says.
awesome.
Equivalent of a level 1 tech kinda job, smile.
So more names to identify the data at different layers, but don't let it confuse you. You will learn this over time. Just to confirm your understanding of the independence of each of these layers, each layer considers any data that it gets from a layer above it as a payload. So for example, at the transport layer, that software thinks this data is the payload, and then the layer 3 network layer software, right, considers everything above the network layer the payload, and at the layer 2 they consider everything above layer 2 the payload, right? So this can be a little bit confusing when you're getting started. Most network engineers consider the data the actual payload and everything else the encapsulation, but different people can use the term payload to mean different things. So expect
Symmetric says.
I can make a metaphor for this.
I don't think so, Magic User. I mean, I just, people like, especially users, and I've done it. I think we've all done it. Like, you get the machine to work, you know, just to get it to work so you can get your job done. I mean, like, we've all had little fixes, you know, here and there just to get our computer to work, to get our job done. So I don't think they were ashamed. Maybe Loaf will say something different. See.
What he just said, if you didn't understand it.
Loaf says.
I think they were like, my fix is quicker, even though we have spare cables. Perhaps they couldn't find me when it happened and then forgot. I don't know how they didn't complain that their system wasn't slow though. Damn thing was painful to use.
Right.
Symmetric says.
Slow equals less work for them equals easier job.
That doesn't translate. Stop it. That doesn't translate. Especially now. The emails pile up. the work piles up. It just sits there in a queue. It just sits there in a queue. Unless you're you're working at Panera Bread, and you can only do like, with a group of 5 line cooks, you can only make one item at a time. Like I don't think that translates anymore for most modern IT jobs, or information technology or information worker jobs.
Lolulo.
Loaf says
10 MB/s equals painful IT. I'm gonna make a side channel to painful IT called 10 MB/s.
That's awesome.
Metric says
You do that. I'll start the merch shop. Equals.
Hack the Planet says
Yay, this happens all of the time in the IT world. I'll find out months after an event actually happened just because a user would rather work around the problem than let us know about it.
Right.
Metric says
Painful it calendar incoming.
I need to commit to something, because this is what I have. Actually, I could be working on this now. There's literally a login up here. There's actually a login.
Magic User says
I'm not new to IT issues. I've worked in it over a decade. I was literally only interested in that person in that example. OD.
Loaf says
Oh, all right.
Dang. Web link.
Oh, Jesus. What are the odds? We can make it something else though. It doesn't have to be .com, right? So this is what I got. I mean, these are what I wanted to do for vacation. I wanted to have these done for vacation, but it doesn't make sense right now. Paper Street Soap Company, that's from Fight Club. Hooper Oceanographics, that's from Jaws. That's a great beach t-shirt. Flossed in Paradise, from The Fifth Element, and Fratelli's Family Restaurant, from Goonies. But this is the mock-up I had made for the channel.
Loaf says
It was a joke anyway. XD. Hold up though. Know who is information for. Web link. XD.
translated from Spanish.
Anyways.
That's even more painful.
IT isn't a .pro. Why is .sh so expensive?
Wystone says
.tech.
0 Mbps. Yeah, but 0? Do we want 0 or 5? Holy shit. Yeah, we don't want 2. Anyways, I can fidget and look at this stuff and try to tweak this stuff forever. What does PDU stand for? Protocol Data Unit.
Just to confirm your understanding of the independence of
There's a .tech one.
each layer considers any data that it gets from a layer above it as a payload. So, for example, at the transport layer, that software thinks this data is the payload, and then the layer 3 network layer software, right, considers
That's not bad.
Loaf says.
And at the layer
Web
2,
link.
No, there's not.
Translated from Estonian.
right? So this can be a little bit confusing when you're getting started. Most network engineers
This will not be cheap.
the actual payload, everything else the encapsulation, but different people can use the term payload to mean different things. So expect that.
We've looked at these before. 7h30it.com. Interesting. Oof. Okay, the water's running through me. Hold on real quick.
Loaf says.
Dino dance.
Explain how switches and routers use MAC and IP addresses.
Once a device transmits a frame on the
Okay.
network, the first device that receives the frame is a switch. The switch is called an invisible hop, which means the switch does not modify the source or destination MAC.
Panic Gamer, thank you for your resub.
Pinakama 9 says.
18 months.
Translated from Spanish.
How you doing? 18 months. That's wild. I appreciate the support. Thank you, Panic Gamer.
Just woke up. How you doing, sir?
I'm good. Hanging in there. I'm good. Small Beanie Hacker had a soccer tryouts this morning, and we are down until about 5 o'clock, 5:30. My nephew's birthday party's today, 6:30. Takes about an hour, so 5:30.
Device transmits a frame on the network. The first device that receives the frame is a switch. The switch is called an invisible hop, which means the switch does not modify the source or destination MAC address in the frame before forwarding it on to the next location in the forwarding path. What it does do is it validates the checksum,
Hack the Planet says,
examines the source MAC address.
I love how the
to
command
see
doesn't iterate the variable, so I always only have one ticket. D.
I don't know. It may tell you, right? It doesn't iterate it. I don't. You may have more. You may have more. It doesn't matter. I have no idea when I'll be able to do another giveaway. I don't even know where it's at. Is it just a command? Doesn't look right. There's nothing there.
Don't fix it. It's great. D.
There's no chat commands. Whatever. Whatever.
Once a device transmits a frame on the network, the first device that receives the frame is a switch. The switch is called an invisible hop, which means the switch does not modify the source or destination MAC address in the frame before forwarding it on to the next location. Forwarding path. What it does do is it validates the checksum, examines the source MAC address to see if this is a new MAC address that should be added to the Ethernet switching table that's used to forward frames. It consults the destination MAC address in the frame and the Ethernet switching table to determine the outbound interface and forwards the frame on to the next location in the forwarding path. The frame that the computer transmits on the network includes the destination MAC address of a next hop device. You'll hear the term next hop a lot in the networking world. And what the next hop is, we're talking about a router that's on the same network as the connected device, in this example, the computer. So the frame that the switch receives will include the source MAC address of the computer and the destination MAC address of the router, and that's the next hop device. So the switch doesn't modify the source or destination MAC address in the frame. It simply uses the destination MAC address and its switching table to forward the frame out the correct interface so that it can arrive at the next hop device or the router for additional processing.
I'm gonna have to watch this a couple times. This is starting to get deep, so.
Let's look at what the router does. The frame just got there. What does the router do now? It looks at the layer 2 header, consults the destination MAC address in that header, and realizes, this is for me, that's my MAC address, that's on this inbound interface. I need to process this packet a little further. Let me examine the layer 3 header. That's where the source and destination IP address are located, so I look at the destination IP address in the layer 3 header in the frame, and I realize that's not my IP address, so this packet isn't for me. Let me consult my routing table. And if I'm thinking positive, I have a route to this destination, and I learn two things. The device will learn the next hop for the route. Now remember, the next hop is an interface that's on a router that's directly connected to me. And I learn my outbound interface to reach that next.
I'm not even here.
What does the router do now? It looks at the layer 2 header, consults the destination MAC address in that header, and realizes, this is for me, that's my MAC address, that's on this inbound interface. I need to process this packet a little further. Let me examine the layer 3 header. That's where the source and destination IP address are located, so I look at the destination IP address in the layer 3 header in the frame, and I realize that's not my IP address, so this packet isn't for me. Let me consult my routing table. And if I'm thinking positive, I have a route to this destination, and I learn two things. The device will learn the next hop for the route. Now remember, the next hop is an interface that's on a router that's directly connected to me, and I learn my outbound interface to reach that next hop. And that's key because, see, that router is going to strip off that layer 2 header and put a new one on there. And the source MAC address will be the MAC address on the outbound interface of that router. And the destination MAC address will be the MAC address of the interface that is on the next hop device that I'm directly connected to. So a key thing to remember here is each router in the forwarding path will perform that same operation until the traffic reaches the ultimate destination. Remember, the primary job of a router is to analyze the destination IP addresses in the layer 3 headers of the packets that it receives and consult the routing table to determine the outbound interface and the next hop for the traffic. So all routers will process the layer 3 header and replace the layer 2 header with the appropriate source and destination MAC addresses. One unique characteristic of IP addresses is they are considered logical addresses. This means that they can be modified through configuration. So the computer has IP addressing that was configured either manually or dynamically, but it can be changed at any time. And the same thing with the routers. The IP addresses on the interfaces were configured by somebody like you, a network administrator. Remember, the MAC addresses are physically burned in by the manufacturer. So there's a little bit of difference in how those addresses are managed.
Again, let me grab some water. I'll be right back. I'm out of coffee. I'm done with the coffee. Where'd the water bottle go? Oh, here. Be right back. I brought snacks. Madam Fabulous.
Let's review your understanding of how data is processed as it traverses the network. Our scenario is this. Host A has encapsulated some data. It has also translated it into binary format and transmitted some pulses on wire. Now the data's arrived at the switch. Let's verify your understanding of what happens next. Let's review your understanding of how data is processed as it traverses the network. Our scenario is this. Host A has encapsulated some data. It has also translated it into binary format and transmitted some pulses on the wire. Now the data's arrived at the switch. Let's verify your understanding of what happens next.
Morning.
Let me ask you a question. What are the MAC addresses in the layer 2 header when the frame arrives at the switch? If you said the source MAC address, let me ask you a question. What are the MAC addresses in the layer 2 header when the frame arrives at the switch?
What are the MAC addresses in the layer 2 header when the frame arrives at the switch? The source MAC address, which is the host. Oh, it's right here. And then, okay, so it's not the destination MAC address, it's the MAC address of the router.
If you said the source MAC address is the MAC address associated with the outbound interface on host A, and the destination MAC address is the MAC address associated with the inbound interface on the router, you are correct. Let me ask you another question. What are the source and destination MAC addresses after the frame leaves the switch?
After it leaves the switch, it looks like it's still the host of the machine that's sending it and the MAC address of the router, inbound to the router.
If you said the source MAC address is still the MAC address associated with the outbound interface on host A, and the destination MAC address is still the MAC address associated with the inbound interface on the router, you are correct. You remember that the switch is the host that makes the hop. It does not modify the source or destination MAC addresses in the frames of the processing. Good job.
Oh, he's not saying anything there.
A bit of a review here. Remember that when that frame arrives at the router,
Wait a minute. I meant to redo these.
Once a device transmits a frame on the network, the first device that receives the frame is a switch. The switch is called an invisible hop, which means the switch does not modify the source or destination MAC address in the frame.
Gun Void Walker says,
I have a question. And it's not my intention to irritate. Why do pentest scrubs like us have to learn the basics of networking in such detail?
It's like, I don't know. It's what we're dealing with. It's what we're trying to manipulate. I think we have to have a basic understanding of the fundamentals to get better at and excel at what we're trying to manipulate. Or are you telling a joke? Is there a joke in there? Apple ASMR.
Yes, I agree. Why the details though? I'm serious.
Why the details? To get a better understanding of what we're trying to manipulate. Maybe I'm not understanding the question. SW Official, thank you for the follow. How you doing today?
Loaf says,
If you don't fully understand how something works, how to exploit might not be as intuitive.
Gun Void Walker says,
Yes, frame, packet. Really?
I mean, it could be anything. It doesn't, I don't think it's necessarily like pointing to frame and packet specifically. Like, if you're cooking something, I think everyone knows how to cook on a basic level, right? But let's say you're baking a cake, right? Like, baking is a science. Like, it's exact. If you try to like put in a heaping mound of flour, or maybe you don't sift it, or I don't know, you don't know how to pull the yolk out of an egg, like, or you don't understand the conversion methods between teaspoons and tablespoons and cups and ounces and that kind of thing, or the understanding of how much less something cooks if you don't preheat an oven, or proofing bread. Like, a lot of that stuff is like, isn't like common knowledge. Like, if you walk into a kitchen, you see the burners, you see there's microwaves, you see there's spoons and stuff like that. But if you don't know how to use those tools, you don't understand why things are a certain way, you risk burning something. You risk flat bread. You risk, does that make sense? You risk, yeah, you risk
formula of baking soda. Doppelpunkt.
Right, or baking soda. Like, that's a good one, actually. You may understand that you need a teaspoon of baking soda for something that you're making, and that helps it come out light and fluffy, right? But you may not understand on a molecular level how that works.
Loaf says,
There's following instructions, a recipe, to make your food, but the person who invented that cake understood how everything fits together without instructions, or they went through many iterations to understand how it fits together in order to achieve the desired outcome.
I like that explanation more than mine. I like that explanation more. Well, SW official, I hope you're okay. Thank you for the follow. I've always said that I don't want to memorize this stuff. I want to understand it. I want to understand what I'm doing. And I think that's why it's taken me longer than most. Like I don't want to just memorize it.
Forwarding it on to the next location in the forwarding path. What it does do is it validates the
Loaf
checksum,
says,
examines the
Someone can
source
tell you
MAC
how to
address
hack
see
something,
if this is a
and you
new
might
MAC
even
address
be
that
able
should
to
be
do it by
added to the
following their
Ethernet switching table
instructions. But
that's
if
used
you're
to
on your own
forward.
and face something new to hack and there's no one to guide you, you need to pull on your own knowledge, experience, and understanding to win.
That.
Alexonist says,
Hey my beautiful friend, you
Alex.
better get ready. This Christmas I shall give you a jersey of the best American football team,
Poof.
Broncos.
Absolutely not. John Elway haunted my dreams as a child. Absolutely not.
How are you though? Jinx lol.
Gun Void Walker says,
Should I learn critical thinking?
Yes. Next question.
It consults the destination MAC address
I'm well, Alex. Hope you are too.
and the Ethernet switching table to determine the outbound.
Start over.
Once a device transmits a frame on the network, the first device that receives the frame
Loaf
is a switch.
says,
If you're asking that question, you surely already know it.
Gun Void Walker says,
I rest my case.
I got no idea what case you're trying to make. No clue.
What was my question?
Alexonist says,
I'm in bed tired AF. I was going to check these free courses of Juniper Networks as well.
It's called an invisible hop, which means the switch does not modify the source or destination MAC address in the frame before forwarding it on to the next location in the forwarding path. What it does do is it validates the checksum,
Loaf says,
examines the source MAC
Critical
address to
thinking
see
is a tool.
if this is a new
Just
MAC
because
address
you have
that should
it,
be added
don't
to the
mean you
Ethernet
know how
switching
something
table
works.
that's used to
You
forward
still need to
frames.
use the tool
It
and do
consults
the
the destination
legwork.
MAC address in the frame and the Ethernet switching table to determine the outbound interface and forwards the frame
Gun
on to
Void
the
Walker
next
says,
location. in the
Invisible
forwarding path.
hop. Okay.
The frame that the computer transmits on the network includes the destination MAC address of a next hop device. You'll hear the term next hop a lot in the networking world. And what the next hop is, we're talking about a router that's on the same network as the connected device, in this
Loaf
example, the
says,
computer. So the
Trace route
frame
is
that
a
the
great
switch
example of
receives
invisible
will
hops,
include the
Tom.
source MAC address of the computer. Once a device transmits a frame on the network, the first device that receives the frame is a switch. A switch is called an invisible hop, which means the switch does not modify the source or destination MAC address in the frame before forwarding it on to the next location in the forwarding path. What it does do is it validates the checksum, examines the source MAC address to see if this is a new MAC address that should be added to the Ethernet switching table that's used to forward frames. It consults the destination MAC address in the frame and the Ethernet switching table to determine the outbound interface and forwards the frame on to the next
Loaf says,
location.
You'll see every router that decrements the TTL, but you won't see any switches.
Hack the Planet says,
The evidence is there. Users across the planet use computer networking without the slightest understanding about how it all works. But there are experts behind the scenes, who, because they intricately understand the details, are able to troubleshoot and resolve issues with networking when those issues arise.
Alexonist says,
I need to do a reverse proxy on my VPSX stacks. I'm in lazy potato though.
I can help you with that. I don't know why I pushed that button. Would you like a timeout, Alex?
Gabriel Ribeiro on YouTube says,
Hi.
Gabriel
Alex
Ribeiro.
Honest
Hi.
says,
Jinx level.
translated from Romanian.
How you doing today, Gabriel?
Jerksty.
Only cozy we love you, Alex. Here's your bump. Good luck on your proxy.
Hack the Planet says,
I reversed my proxy once. It caused me great pain. D.
In the forwarding path. The frame that the computer transmits on the network includes the... Once a device transmits a frame on the network, the first device that receives the frame is a switch. The switch is called an invisible hop.
Only because we love you, Alex.
Does not modify the source or destination MAC address in the frame before forwarding it on to the next location in the forwarding path. What it does do is it validates the checksum.
Gabriel Ribeiro
Examines
on YouTube says,
I love your lives. I take the opportunity to study with you. A hug from Brazil.
Gracias. Thank you. Kind words, Gabriel. Thank you. What are you studying before you mute me so you can focus? I feel like I cut myself. No? No.
Switch is called an invisible hop, which means the switch does not modify the source or destination MAC address in the frame before forwarding it on to the next location in the forwarding path. What it does do is it validates the checksum, examines the source MAC address to see if this is a new MAC address that should be added to the Ethernet switching table.
Okay.
It's used to forward frames. It consults the destination MAC address in the frame and the Ethernet switching table to determine the outbound interface and forwards the frame on to the next location in the forwarding path. The frame that the computer transmits on the network includes the destination MAC address of a next hop device. You'll hear the term next hop a lot in the networking world. And what the next hop is, we're talking about a router. A router that's on the same network as the connected device, in this example, the computer. So
I really wish they'd show
frame that the
shit like
switch
Wireshark
receives
so you can
will
see
include
what the shit
source MAC
actually
address
looks
of the
like.
computer and the
So
destination
you
MAC
can put a
address
name to a
of the router,
face
and
or
that's the
WE.
next hop device.
I hear you.
So the switch doesn't modify the source or destination MAC address in the frame. It simply uses the destination MAC address and its switching table to forward the frame out the correct interface so that it can arrive at the next hop device or the router for additional processing. Let's look at what the router does. The frame just got there. What does the router do now? It looks at the layer 2 header, consults the destination MAC address in that header, and realizes, this is for me, that's my MAC address, that's on this inbound interface. I need to process this packet a little further. Let me examine the layer 3 header. That's where the source and destination IP address are located, so I look at the destination IP address in the layer 3 header in the frame, and I realize that's not my IP address, so this packet isn't for me. Let me consult my routing table. And if I'm thinking positive, I have a route to this destination, and I learn two things. The device will learn the next hop for the route. Now remember, the next
When you
hop
get
is
the
an
time,
interface that's
you
on
should
a router
watch a
that's
video
directly
like
connected
this,
to me,
web link.
and I learn my outbound
What the fuck is viewing and decoding UART or serial data on an oscilloscope? Symmetrics. God love you that you think
It kinda has the same to do with what you're learning in some sort of adjacent thought.
Okay.
Gun Void Walker says.
Art is important. Weht it's 2025. I love old tech.
To see and decode the UART or serial data on an oscilloscope, we first need an UART signal. For that, let's grab a breadboard, and for the signal, I will use an Arduino to generate.
What the router does.
Metric
The frame
says.
just got there. What does the router
It
do?
shows how the data
It
is
looks at the
physically
layer 2 header,
transported as it's
consults the
captured by
destination
the
MAC address in that
oscilloscope.
header and realizes,
The scope
this
is
for me.
enigma
That's
in
my
this
MAC
video.
address. That's on this inbound interface. I
Or
need
like
to process
physical
this
Wireshark.
packet a little further. Let me examine the layer 3 header. That's where the source and destination IP address are.
I can appreciate that. I'll check it out.
IP address in the layer 3 header in the frame, and I realize that's not my IP address, so this packet isn't for me. Let me consult my routing table. And if I'm thinking positive, I have a route to this destination, and I learn two things. The device will learn the next hop for the route. Now remember, the next hop is an interface that's on a router that's directly connected to me, and I learn my outbound interface to reach that next.
It's not so much about animations or overlays. It's more about just a foundational knowledge. Like, I've learned what I need to learn from this to do a job. But
This is for me. That's my MAC address. That's on this inbound interface. I need to process. Let me examine the layer 3 header. That's where the source and destination IP address are located. So I look at the destination IP address in the layer 3 header in the frame, and I realize that's not my IP address. So this packet isn't for me. Let me consult my routing table. And if I'm thinking positive, I have a route to this destination, and I learn two things. The device will learn the next hop for the route. Now remember, the next hop is an interface that's on a route.
oh shit, Rob's at Micro Center. Sorry, I just saw someone go live that I was... Tennis.
Do I have like metal between us, or what's going on, right? So my fix for it is to just move the Wi-Fi router into that room and then run a hardline Cat6 from where the cable is to the, I mean, it's a super simple solution, it's very best and cheapest. But then I kind of am going to be iffy in the back rooms, in the bedroom, and then the bigger house. But I'm not, I don't have a house right now for that, so. But I'd like the option if I was going to do that. Do you have a preference in your router brand, or are you more like a Netgear? Or are you doing?
Crispy, how you doing? How often do I take notes? It depends. If I'm doing like boxes, if I'm doing try hack me boxes or hack the box, I'm typically taking notes after I've completed the box and I go back again. I'm more of a hands-on like learner. So this is very much out of my what I normally do. That's why I'm going back over and over again, and I'm rewatching them, because it only really sticks if I understand what the concept is that they're trying to convey. And besides, all my notes are here if you want to take a look at them.
It's got there. What does the router do now? It looks at the layer 2 header, consults the destination MAC address in that header, and realizes this is for me. That's my MAC address. That's on this inbound interface. I need to process this packet a little further. Let me examine the layer 3 header. That's where the source and destination IP address are located. So I look at the destination IP address in the layer 3 header in the frame, and I realize that's not my IP address. So this packet isn't for me.
Baby Sean, it's all good. How you doing today?
What are the source and destination MAC addresses after the frame leaves the switch? A bit of a review here. Remember that when that frame arrives at the router, the layer 2 header is removed. The frame of the computer.
Okay.
Let's look at what the router does. The frame just got there. What does the router do now? It looks at the layer 2 header, consults the destination MAC address in that header, and realizes this is for me. That's my MAC address. That's on this inbound interface. I need to process this packet a little further. Let me examine the layer 3 header. That's where the source and destination IP address are located. So I look at the destination IP address in the layer 3 header in the frame, and I realize that's not my IP address. So this packet isn't for me. Let me consult my routing table. And if I'm thinking positive, I have a route to this destination, and I learn two things. The device will learn the next hop for the route. Now remember, the next hop is an interface that's on a router that's directly connected to me, and I learn my outbound interface to reach that next hop. And that's key, because see, that router is going to strip off that layer 2 header and put a new one on there. And the source MAC address will be the MAC address on the outbound interface of that router. And the destination MAC address will be the MAC address of the interface that is on the next hop device that I'm directly connected to. So a key thing to remember here is each router in the forwarding path will perform that same operation until the traffic reaches the ultimate destination. Remember, the primary job of a router is to analyze the destination IP addresses in the layer 3 headers of the packets that it receives and consult the routing table to determine the outbound interface and the next hop for the traffic. So all routers will process the layer 3 header and replace the layer 2 header with the appropriate source and destination MAC addresses. One unique characteristic of IP addresses is they are considered logical addresses. Remember, the primary job of a router is to analyze the destination IP addresses in the layer 3 headers of the packets that it receives and consult the routing table to determine the outbound interface and the next hop for the traffic. So all routers will process the layer 3 header and replace the layer 2 header with the appropriate source and destination MAC addresses. One unique characteristic of IP addresses is they are considered logical addresses. This means that they can be modified through configuration. So the computer has IP addressing that was configured either manually or dynamically, but it can be changed at any time. And the same thing with the routers. The IP addresses on the interfaces were configured by somebody like you, a network administrator. Remember, the MAC addresses are physically burned in by the manufacturer. So there's a little bit of difference in how those addresses are managed. Let's review your understanding of how data is processed as it traverses the network. Our scenario is this. Host A has encapsulated some data. It has also translated it into binary format and transmitted some pulses on the wire. Now the data's arrived at the switch. Let's verify your understanding of what happens next. Let me ask you a question. What are the MAC addresses in the layer 2 header when the frame arrives at the switch?
The MAC addresses in the layer 2 header. Where's layer 2? Right? This is layer 2. The source is going to be host A, and the destination is going to be the first router, because this is what do they call it? Invisible hop, a switch.
If you said the source MAC address is the MAC address associated with the outbound interface on host A, and the destination MAC address is the MAC address
Inbound.
with the inbound interface on the router, you are correct. Let me ask you another question. What are the source and destination MAC addresses after the frame leaves the switch?
That's the same, because of the invisible hop shit. Okay.
If you said the source MAC address is still the MAC address associated with the outbound interface on host A, and the destination MAC address is still the MAC address associated with the inbound interface on the router, you are correct. You remember that the switch is an invisible next hop. It does not modify the source or destination MAC addresses in the frames that it processes. Great job. A bit of a review here. Remember that when that frame arrives at the router, the layer 2 header is removed, and the router analyzes the layer 3 header and consults a routing table to determine the next hop in the forwarding path. Now that the next hop in the forwarding path has been determined, the router...
Hold on.
A bit of a review here. Remember that when that frame arrives at the router, the layer 2 header is removed, and the router analyzes the layer 3 header and consults a routing table to determine the next hop in the forwarding path.
Switch and MAC address, and then router. Right, okay. So the frame header and the frame trailer get peeled off, and then it looks at the packet header. I don't know if hub is the same as a switch. In this instance, what I'm understanding is that this is a switch.
A bit of a review here. Remember that when that frame arrives at the router, the layer 2 header is removed.
Yeah.
And the router analyzes the layer 3 header and consults a routing table to determine the next hop in the forwarding path.
Right.
Now that the
Good morning, Tawny. What are you having problems with? Nothing. At the moment. Scott B, good to see you. No, what I'm doing right now is just understanding what goes on at each of those levels. We've learned that the switch is an invisible hop, so the PDU that's running from the source IP to the next hop would be the MAC address for this computer, and the destination would be the MAC address for this router. That's not the first time Tony said that to me. So I got a an upcoming in-person interview that uses Juniper hardware. So I am brushing up on my networking. Oh, we can get your mom joke out of it. Don't worry. Sure.
Next hop in the forwarding path has been determined. The router can discover the MAC address on the outbound interface of the directly connected peer and use that information to create a new.
Sorry.
Now that the next hop in the forwarding path has been determined, the router can discover the MAC address on the outbound interface of the directly connected peer and use that information to create a new Layer 2 header. The new Layer 2 header will include new source and destination MAC addresses, and a new frame checksum will be calculated and added to the trailer. Now the frame is ready to be transmitted to the next hop in the forwarding path.
So it's talking about this area right here.
I do have another question for you. What actions are performed by the next routers in the forwarding path?
They will read and replace. Which headers? The song is down here. Right here. How you doing, MU30? As they've described it, what gets stripped off is we're still on the network layer. So it reads the packet header and then replaces it.
Let's go to the next slide for the answer. The next two routers in the forwarding path perform the same actions that the first router performed. They remove the Layer 2 header,
here,
discover the next hop in the forwarding path, and create a new Layer 2 header with a new checksum and forward the frame to the next location in the forwarding path. I do have another question for you. When the frame leaves router B, what's going to be the destination MAC address?
It'll be the destination IP's MAC address.
If you said that the destination MAC address is the MAC address on the inbound interface on host B, you're correct. Great job. You now understand the fundamentals of how data is transported across. It's going to be the destination MAC address. If you said that the destination MAC address is the MAC address on the inbound interface on host B, you're correct. Great job.
The nuance. Generally, the Ethernet frame gets replaced at every level 3 device, which is network. Ethernet frame gets replaced at every L3 device, but the packet header tends to remain intact unless NATs involves.
You now understand the fundamentals of how data is transported across a network.
Yup.
At this point, the data has almost
Yeah.
crossed the It has been transported to the destination device. So what happens next? Well,
How you doing, Gray Hatter?
examine the layer 2 Ethernet header and look for the destination MAC address. And then it's going to ask itself a question. Is this my MAC address? If it is, that means this data is for me, so I should continue processing this frame. If the destination MAC address does not match the device, the frame is discarded. Once the device At this point, the data has almost crossed the finish line. It has been transported to the destination device. So what happens next? Well, the destination device is going to examine the layer 2 Ethernet header and look for the destination MAC address. And then it's going to ask itself a question. Is this my MAC address? If it is, that means this data is for me, so I should continue processing this frame. If the destination MAC address does not match the device, the frame is discarded. Once the device determines that the data is destined for itself, it calculates the checksum of the data and compares it to the checksum that is stored in the trailer of the received frame. If the checksums match, the layer 2 header can be removed and forwarded to the layer 3 software for further processing. Let's see what happens next. Once the layer 2 header has been stripped from the packet, the layer 3 header is examined, and the device examines the destination IP address in the layer 3 header and asks itself another question. Is this my IP address? And that's an important question because remember our good friend the router. A router receives many packets where the destination IP address is not the router's IP address. It's for some other device further down a forwarding path. But since this traffic is destined for this device, the destination IP address in the packet should match, and now the device can forward the data to the layer 4 software for further processing, and the layer 3 header can be removed. Let's continue. The final step before delivering the data to the application is determining which application the data is for. The key piece of information in the transport layer in the layer 4 header is the destination port. Remember that on a host, when an application is launched, it is assigned a unique port number, and that is used to differentiate the multiple applications that are running on an individual device. Remember, I've asked you before in this course, how many applications are you running right now on the device you're using to watch this presentation? I bet it's more than one. And so on one single host with a single IP address, you're able to run multiple applications, and they can be differentiated by this unique port number. So the device will analyze the destination port, determine the destination application for this traffic, strip off the layer 4 header, and now the data is delivered to the application. Maybe you used to think this was magic before, but now you completely understand how data from an application on the side of the network can be encapsulated for transport, transported across the network to a destination device, de-encapsulated for delivery to the destination application. Now you know a lot about networking. Great job, let's keep going. We've talked a lot about layers in this course. We talked about how data is encapsulated and the actions that are performed at each layer, and how data is de-encapsulated when it arrives at a destination and each layer is processed. And remember, there are specific, detailed actions that are performed at each layer. Every layer has a specific, well-defined function. Who defined these functions? Well, there's a group called the International Standards Organization, who defined decades ago something called the Open Systems Interconnect model. And they define exactly what actions must be performed at each one of these layers that you see on the screen. Think of all the devices in your home network that are connected right now. Think of the different types of phones and tablets and televisions and laptops, and they're all able to connect, send and receive data, applications can communicate, because every vendor follows the standards that are defined, the requirements that are defined in this model. I think every network administrator is introduced to this model when they start their career. It's been around, like I said earlier, for decades. It took me a while to understand the parts, so don't be frustrated if you don't understand each layer and what goes on in each layer. You'll pick this up over time, and it'll help you as you get more experience, troubleshoot and understand how networks work. While the OSI model defines the functions that are performed at each networking layer, the actual functions are performed by software. And there's a name for the software that's used at each of these networking layers, and it's called protocols. And what you'll see is that at each layer, there can be multiple protocols that perform the functions that are defined in the OSI model. For example, the network layer, there's a protocol called IP, and its function is to perform addressing and routing of data on the network. Over time, you'll see the different protocols at the different layers that perform the encapsulation and de-encapsulation functions that we've spoken about in this course. Again, we've spoken a lot about these layers in this course. This slide is a summary of what we've discussed. And remember that I mentioned it took me a while to learn the functions that are performed at each layer. Let me help you out. There are some layers that are a little more important to understand for a network administrator. Let's take a look at those now. This slide shows you some of the most important layers for an administrator to understand. Understanding the functions of these layers will help you understand how networks work and to perform troubleshooting. Let's start at the top. Remember the application layer? That's the actual data. That's what all this networking stuff is about. It's the most important thing on the network. Now, the application data, of course, is encapsulated, and the transport layer is used to identify the applications that are exchanging the data. We've talked about port numbers. The network layer is responsible for addressing
IP.
The data link layer
Max.
is responsible for identifying the connected devices using MAC addresses and fabricating frames that can be communicated between hosts. And the physical layer is where we can actually validate whether or not the device is connected to the network. Understanding how these key layers function will help you as a network administrator. UK Network Superstar, you now understand how data is encapsulated, how that encapsulation enables the data to be transported across the network and delivered to a destination application. It's amazing information, and it's how networks work, and it's what networks are all about, and now you know how it works. That's amazing. In a short period of time, you've come a long way. Let's learn some more.
All right, how about a little break? Nope. Where did I go? Oh. I missed your last message there, Tawny. Song, hydrate, equinox, breathe, institute, chicken, rest, start, launch, fling.
Grey Hatter says.
That's smart.
Holy shit.
Tanifar3 says.
That's wise.
I played Wordle only once and got it on the first try. Figured it's all downhill from there, so I don't play it anymore.
That's wise.
Madam Fabulous says.
Moo eyes.
Grey Hatter says.
I just lost power for long enough to reset everything. Sigh.
Strain, stretch. Institute, start, launch.
Tanifar3 says.
So you had an unpowered PC.
Found, number, strain, onion, stretch. Air, fling, rest, chicken, breathe, equinox, hydrate. I don't think that's it. Let's try something else. Song, hydrate.
Loaf says.
Breath, stretch, hydrate, strain. All exercisey words.
Stretch, hydrate. I don't think strain. Rest. Good looking at. Oh, tips for working safely.
Eat, sleep, rave, repeat. All words to live by.
Smart. Found, air, fling, launch. Start, number, chicken, institute. Institute feels like start. Launch. Found. There it is. Yep. Air, number, chicken, fling. Song, onion, equinox, strain. Number. Fling.
Grey Hatter says.
OMFG.
What happened? Did it happen again? We didn't get the easy one yet. There's an easy one here. The easy one and the hard one's left.
Is it gonna be a 3, 4, 5, 6 word length?
Grey Hatter says.
Ugh.
Home Assistant changed its system user ID.
That sucks. That would suck. I hate those kinds of connections. There's an easy one and a really hard one here. How come I can't pick out the easy one? Song, onion, equinox, chicken and onion, no. Equinox, strain. It's like cooking.
Metric says,
"Come on, you got this."
Grey Hatter says,
"How does someone fuck up this badly?"
Number.
Well, no,
Equinox.
because they weren't using a system user ID.
Loaf says,
"Contains in."
Metric says,
"They listen to that idiot's metrics."
In.
That's how.
Stop it. I don't freaking see it. Air, number, chicken, fling, strain, equinox, onion, song. What the fuck? Like nothing.
Self-deprecation? Not allowed?
Correct, not
Loaf
allowed.
says,
I'm not allowed to do it, neither is anyone
Only
else.
3 that contain in, but lots that contain in.
Metric says,
Shuffle. Equals. You'll see it.
Air, song, onion, strain. Fling.
Until they make more and more sense.
Chicken, song, air, onion, fling, number, equinox, strain. Strain, fling, air.
Loaf says,
"Fling chicken air equinox, over the equator. Throw the chicken over the equator."
Nailed it. Nailed it. I'm one away.
Metric says,
Lamau.
Translated from Haitian Creole.
How are 3 of these related?
Tanifar3 says,
"You can't see it?"
No, I can't see it, or I would have guessed it by now.
I thought you were just messing with us.
Metric says,
When you figure it out, it's gonna fuck you up.
You all are messing with me. Chicken. God. Song, air, strain. Fling, air, strain. Fling, song, strain.
Loaf says,
Is this actually a 3, 4, 5, 6? XD.
Translated from Spanish. Metric says,
God damn. I'm hungry.
Yeah, I'm hungry too.
Aren't you hungry, Theo?
What is it? What, is it wings? It's not wings, is it?
Is it time for lunch?
Deselect. It's got something to do with food. So there's chicken, there's onion.
I'm pretty sure. You'll solve this if you continue to broadcast this stream.
I'm trying to solve some kind of ancient riddle with Symmetrics.
Live on air. Live I.
Translated from Dutch.
Lie.
Trying to get TTS to say live not live lol.
Live, not live.
Loaf says.
Lie.
Translated from Danish. Symmetric says.
Live as alive.
I can't see it. I can't see it. I'm about to guess because I'm getting irritated. And I gotta go to the bathroom again. Chicken, song, air, onion. Fling, number, equinox, strain. Fling? What the? Did he? What? Air? I've heard of like a song being called a little like a ditty.
Symmetric says.
I've got no idea what that is.
Okay, guess.
Fling air song number smile smile.
Tanifar 3 says.
Yay, first was a song.
Symmetric says.
Yay. That's the one I said you're gonna be annoyed when you figure it out.
Tanifar 3 says.
Second, you can put the word spring in front of.
Symmetric says.
Spring chicken.
Tanifar 3 says.
Spring equinox, spring fling, spring onion.
I would have got that
Symmetric
one first.
says.
Spring equinox.
Translated from German.
Spring fling.
Grey Hatter says.
Lamau, I forgot I did that.
Symmetric says.
That's how I solved that one.
Okay, bathroom. Be right back.
Grey Hatter says.
I wrote a Theo helper for my lights. If you call the binary without any args, it'll just print time to read when it flashes the lights.
At Jargos Guam's players on YouTube says.
Opa.
24 raiders from Panko Panko have joined. Smetric says.
Welcome Raiders.
Crocodile Sen says.
What, did you do something to your hair?
Smango64 says.
Whoa!
Something inside of me.
Just missed the raid. Panko, what have you been up to, you little hacker? Huh?
Smetric says.
Opa.
Theo is currently after doing the 1 pound weight loss challenge.
At Jagos Guam's Players on YouTube says.
Brazil.
Translated from Portuguese. Skeleton093 says.
Mighty looking biceps, Mr. Theo.
Panico Panko says.
Docker forensics.
Blush. Docker forensics.
Smango64 says.
Damn them biceps looking mighty tasty though.
Panko, you tell them to flirt with me. Oh, I'm sorry. Riz me up.
Crocodile Sen says.
Cleveland fan base.
Go Browns.
Panico Panko says.
What? I would never.
Skeleton093 says.
Pinko Ponko said no such things.
Smango64 says.
What? Panko would never.
Panico Panko says.
They just see something in those biceps.
Yes.
At Jagos Guam's Players
Thank
on
you.
YouTube says.
Colon trophy yellow smiling, colon trophy yellow smiling, colon trophy yellow smiling.
Smango64 says.
This is all from the heart, Pookie.
Crocodile Sen says.
The beard is good too.
Thank you. Well, thank you for the raid, Panko. Welcome, Raiders, to Painful IT. I'm your host, Theo. I hope you're all doing well. I trust Panko is taking good care of you. We are, I was working on this stuff.
Must use some good product.
On my beard? No, nothing. Nope, nothing. Crocodile Sand.
093 says.
Thank you for the follow.
Panko promoted me to court jester recently.
At Jagos Guam's Players on YouTube says.
I don't understand. Nothing in English, KKKK.
Translated from Portuguese. Crocodile Sen says.
Okay, you won me over.
We were doing this data transmission in a network in Juniper Networks Learning Portal. We've been at it for a few hours, so I was taking a break doing some New York Times puzzles.
Fenmo says.
IT is indeed painful.
Fernmoo? It is, yes, painful IT. Well, thanks for hanging out. Thank you, Raiders. Skeleton, nice to meet you. Crocodile Sand, thank you for the follow. Panko, thank you for the raid. Spamango, 64. Yep.
Skeleton093 says.
The pain is what makes it worthwhile.
I call it painful IT because I'm typically learning something new. And learning something new can be hard. All right, speed run, ready? Yoga class need, Matt. Umlaut rotated 90 degrees. What the F is an umlaut? That is shocking. Amazing. Crazy. Electrical. Blank you the one.
Dominic
R.
with that flow.
Egg cells.
One of the German accents
Yolk?
over their
No.
letters.
Tanifar3 says.
One of two royal
Auxiliary.
sleeping options.
Translated from Somali.
Royal.
Crocodile
King
senses.
size.
Okay, this is Riz, guys. Write this down.
King's bed. That's terrible. Bar seating is a stool. Favorite team of Chicago Pope for short socks. Slices of life.
Fan00 says.
2 dots above a vowel.
Olympic gymnast Raisman. Alec. Albert Alman. I don't know. Request at the end of a restaurant meal. Togo box. I hate 2-letter words. Chris. Medium for Melville or McCarthy. Don't know. Used for wine barrels. Oak. June honoree. Don't know. Umlaut rotated 90 degrees. Exhilarating. I still don't know. That is shocking. Oh my god. Oh my god. 3 letters. 3 words, I mean. Egg cells. I don't know. Slices of life.
Tanifar3 says.
Ignore the translation.
Moments.
Hack the Planet says.
Colon?
Web link.
I guess. I just brute forced that one. Colon. Medium for Melville or McCarthy. Noble. No gel. Nodal. No-tell motel. I don't know. June honoree. Dud.
Fan00 says.
Dude.
Read my chat. I gave you the answer to number 4.
Okay.
It's colon.
Yep, got it. June honoree.
Tanifar3 says.
Oh, so.
Translated from German.
Egg cells. Wow, this is the complete, I have no idea what these things are. Egg cells are...
Hack the Planet says.
Embryos.
Nobel?
Loaf says.
Egg cells ova.
Ova.
Tanifar3 says.
Ova.
Egg cells. Isn't that what you make spreadsheets with?
Well, that's going to be it. So, medium for... novel. A dad. June honoree. Dad.
Ovaries. Ovum. Ova.
Translated from Vietnamese. Hack the Planet says.
Egg cells. I'd say about $8 a dozen nowadays.
Sorry, wrong button. Okay, here it comes.
Fan00 says.
Novel.
Here it comes. You ready? Yep. If you thought I struggled on connections, just wait.
Metric says.
Lol.
Oh, are we gonna luck out? Is it Popeye?
Metric says.
Kiss is easier.
Tiggs is easier. To get his.
Tanifar3 says.
If only Jess was here.
Don't tell Jess. Don't tell Jess what? I'm not cheating.
This prompt is hard for Linux people. We never know who we are. First command on a Linux system is who am I?
Metric says.
This fucking fat fingering today.
Madam Fabulous says.
Stare.
I'm not cheating. Oh my god.
Hack the Planet says,
You're not cheating?
RN Ogumby says,
Stop cheating, cock spank.
Madam
Gumby,
Fabulous says,
what's going on?
Stare, stare, stare.
Oh my god, I'm not cheating! What are we staring at?
Smetric says,
Have you no soul?
Okay, it's not Popeye. Why would it be? Why would it be Popeye? I am what I am. Why would it be?
Hack the Planet says,
We see the reflection in your glasses, stud.
Tanifar3 says,
Stare, stare, stare.
RN Ogumby says,
Stop looking at you third monitor.
I got chat
Life
on both
says,
sides, so I can look at
I
both.
see person bottom right. But I'm Brad.
I am what I am.
Smetric says,
Be human instead.
Hack the Planet says,
Who's miming the answers to you?
Smetric says,
On top left.
When we could just sit outside and talk about life while reminiscing about all the good old times. Playing our songs on the radio, the stars were out shining bright. Lit up on the 4th of July, we party all day and night till the morning sun would come call us home.
Loaf says,
Self.
With the guitar strumming, it's getting late now.
Gotta think how to join that F in there, Theo.
Hack the Planet says,
Alive.
Tanifar3 says,
I see a word. It's I.
Thank you, Tani.
Smetric says,
I see no.
Loaf says,
Mortal.
Grey Hatter says,
Did you get someone yet?
RN Ogumby says,
Yeah, excuses are like assholes, we all got them and they all stink.
Smetric says,
No, he's only mortal.
Tanifar3 says,
I see in other words, it's CHEAT and another one, don't tell Jess.
But I'm not cheating.
Loaf says,
Mortal self.
If there's any cats in the hallway, you better get to stepping.
Well, we could just sit outside and talk about life while reminiscing about all the good old times. Playing our songs on the radio, the stars are out shining bright. Lit up on the 4th of July, we'll party all day.
Smetric says,
Oh God, let him do this individually.
Hack the Planet says,
Yourself.
Loaf says,
I hate this game.
Whoa, self wasn't one. Must be joined to something.
Smetric says,
Yea, your smile, smile.
Ugh.
And B.
I hate this
Which
game.
is cheating.
Well, we could just sit outside and talk about life.
don't know why I play that game. Because I'm trying to get better at word searches, but ugh. Yuck.
RN Ogumbi says.
That's how we know you was cheating.
I wasn't cheating.
Hack the Planet says.
Web link.
Smetric says.
Tiles is fun.
Loaf says.
I like that much more than the word groups.
Madam Fabulous says.
More or less than Spellbound?
Oh, no, I like playing Spellbound. I just don't like losing to Spellbound. I don't like Spanagram. There's a difference. Spellagram, Spanagram, strands. This is loosely a game. I don't know how to do binary. I think you add this stuff, but I don't know how to do it. Tiles, huh?
Smetric says.
It's easy.
Hack the Planet says.
Guide is at the top.
Smetric says.
You can do it.
Hack the Planet says.
And bottom.
Stone says.
I'm so playing this.
RN Ogumbi says.
And you'll call yourself a hacker.
Ugh.
Smetric says.
Each tile is stacked with shape parts.
Oh, I see it now. That's why it wouldn't let me.
Match as you go.
So they don't have to match exactly. They just have to have the shapes in there somewhere. It's like this one and this one. Whoops.
This increases pattern matching skills. Yay.
What? Yeah, it is. Oh, it's opposite. Dickhead. Oh, colors are off. This one and this one.
Funny how you're looking at the rearmost patterns first, lol.
Smetric says.
I have yet to successfully clear the entire board in one combo.
RN Ogumbi says.
Binary is easy, bro. Your mom is my binary.
Smetric says.
In positive it can be done.
Nothing else matches. Why didn't the game just end? Nothing else matches.
RN Ogumbi says,
Yes, it does.
Those are the same effing color? Those are not the same color.
That pattern is that same.
Grey Hatter says,
They are.
I can't see it.
It's half-sicles, not two-tone circles.
Hack the Planet says,
:D.
Okay. What am I doing? Guide is at the top and at the bottom.
Match the binary to the number at the right.
Loaf says,
Set the binary digits equal to what the number is in the right-hand column.